Hello friends, this video on equilibrium part 27 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. So as I told, there are a lot of definitions of acid and base. So the first good definition for acid came by Arrhenius. So he told that, according to him, the acid is a substance which dissociate in water to give H plus ion, and the base are the one which produce OH minus ion. So his definition was H plus ion, OH minus ion. The one which gives H plus is acid, one which gives OH minus is base. That was his definition of acid and base. It was a very popular definition, and the reactions are like this. You have acid HX, it will give H plus and X minus. H plus, it gives the acid, and it also told that H plus is very reactive, right? So it forms hydronium ions. So H plus actually is very reactive. It will react with water to form H3O plus ions. So this is the reaction actually. So normally HX in E acid with water, it gives hydronium ions and X minus. That's the actual thing actually happens. But H3O plus, if you remove water from that, it becomes H plus. This is the theoretical, and this is what happens actually. Right? So that was his definition. Similarly for base, if you see MOH is a base which in water gives M plus and OH minus ions, right? And if you see the hydroxyl line which we have got, it also exists in the hydrated form in the aqueous solution. But there's a demerit for this, because if you see everywhere this guy is talking about aqueous solution, right? Aqueous solution. But this definition, that means, is applicable only for aqueous solution. There's a demerit for this, that this is applicable only for aqueous solution, and it doesn't account for the basicity of substance like ammonia, because ammonia is something which will not produce hydroxyl ion, but still it is base. It will convert the litmus paper to blue. But with this definition, it is very difficult to say whether ammonia is acid or base, because ammonia is not in OH minus ions. So his definition was kind of not very concrete. Maybe 98% of the case, his definition is correct, because most of the thing we use the aqueous solution for chemistry reactions, but that is not true. There are some reactions where we don't have aqueous things, and there are some reactions which doesn't gives OH minus ion, for example ammonia, and that's still a base. So this definition was not that great. Then came Bronson and Lowry. There are two people, and they gave the definition of acid and base. They told that acid is a substance that is capable of donating H plus ions, and base are a substance which is capable of accepting H plus ions. So the OH minus ion was the issue there earlier, if you see the ammonia case. So they removed the OH minus ion, they ignored the OH minus ion part. What now they are saying is something which can accept H plus is base, something which can give H plus. So acid, if you see, will give H plus, and base, if you see, will take H plus. That is what they told. Acid will give H plus, base will give H plus, base will take H plus. So with this, ammonia can easily be said as base, because ammonia in water give NH4 plus ion and OH minus ion, right? This guy is ammonia is taking H plus, right? NH3 became NH4 plus, so it is a base. Correct. And with this Bronson and Lowry acid and base, the concept of conjugate acid and base also came. So what is conjugate acid and base? If you see the base, with this base I got one conjugate acid, right? So with the base I got one conjugate acid, and it differs only by H plus ion, if you see, right? That's why I say the acid base pair that differs only by one proton, that is H plus ion, is called conjugate acid base pair. So if you see NH3 and NH4 plus is a acid base pair. Here also if you see H2O and OH minus ion, they differ only by H plus. So they are also acid base, conjugate acid base pair, right? So this is acid, it will be conjugate base. Correct? Base, conjugate acid. So on base, if you add H plus, it becomes conjugate acid. In acid, you subtract H plus, it becomes conjugate base. So the rule is pretty simple. The difference is only H plus ion, but on base, if you add H plus, then only this guy is having potential to give H plus, right? And then it will become acid. See, acid is something I told which is potential to give H plus ion, right? So in base, if you're giving H plus, then only whatever compound you get, example NH3, I gave I gave H plus. I mean this NH3 got one H plus, it becomes NH4 plus. Now NH4 plus is not capable of giving H plus. Maybe it may give, right? If you talk about the reverse reaction, NH4 plus is becoming NH3, right? So NH4 plus, if you just flip this side, NH4 plus is giving NH3. That means NH4 plus is a acid here, because acid is something which gives a proton, correct? So NH4 plus is a acid here. OH minus, if you see, is the base, because OH minus is something which will accept one proton to become water. So if you see the reaction from the flip side, you'll see that in NH3 takes H plus, becomes NH4 plus, and from here NH4 plus gives H plus to gives NH3. So if you see from this side NH3 is a base, if you see from this side NH4 plus is the acid. So they are called conjugate acid because they differ only by H plus ion. But from a base, if you want to make conjugate acid, you have to give H plus ion, add H plus ion. From acid, if you want to make conjugate base, you have to remove. We'll discuss more about this in the next two slides, right? So OH minus is called conjugate base of H2O, and NH4 plus is called conjugate base of NH3, as I told you. And also, if this acid is a strong acid, then the conjugate base is a weak base. And if the base is strong, right, the conjugate acid is a weak. So it's a vice versa always. So for a strong acid, the conjugate base is weak. For a weak acid, conjugate base is strong. Okay. Because I'll tell you, NH3 is a weak base. Somehow it got H plus, it becomes NH4. But this guy, if you see the reverse reaction, this guy will be eager to give one H plus and becomes NH3 again. So this guy is more eager to give H plus, right? So this guy is less eager to take H plus, but this guy is more eager to give H plus, because NH3 is a little stable thing, right? So it's a weak one. This guy is weak, this guy is less eager to take one H plus. So it's a weak base, but this guy is more eager to give H plus back to the system. So this guy is a strong acid. Let's take more about conjugate acid base pair. So as I told, they differ only by H plus ion. So in acid, if you acid will anyway give H plus, let H give H plus. So what you get is conjugate base. Base will obviously take H plus, then it will become conjugate acid, right? And if it is strong, this becomes weak. If this is weak, this becomes strong. Correct? Hope you understand. It differs only by H plus ion, and the way you look is, for example, NH3 is a weak base. It is not eager to take H plus, but somehow it took H plus. Now this becomes a conjugate acid, and this guy will be more eager to give H plus back, so this becomes strong acid. Okay. Let's take one question. What does it mean by conjugate acid base pair? We just discussed, right? Acid base pair that differs by H plus is called conjugate acid base pair, and we define the conjugate acid or base for this following species: HNO2. So HNO2 can take proton or can give protons. I think if you give proton, it becomes NO2 minus. Cn minus, there is no way it can give proton, it has to take proton, right? Plus, this guy is minus. Then we have HClO4. This guy also will give, this is acid, I know, So this becomes ClO4 minus. F minus, it can never give proton because there is no proton here, so it will add one proton. OH minus, we know that it generally take one H plus to becomes H2O. Right? Then we have CO3 minus 2. Also, it can't give any proton because there is no proton here. So this will become SCO3 minus. S2 minus also, it doesn't have any proton, so it will take one proton. This becomes HS minus. Correct. This is how you create acid-base conjugate pair. So the question says we have to find the conjugate base for these acids. So to find conjugate base for the acid, what to do? You take the acid, subtract H plus ions, you get conjugate base. Correct? That's what we discussed. You take acid, you subtract H plus ion, you get conjugate base. So you have HF, you subtract H plus ion, you get F minus. You have H2SO4, you subtract H plus, you get HSO4 minus. You have HCO3 minus, you subtract H plus, you get CO3 2 minus. These are my conjugate. Easy one. Find the conjugate acid for the base. So I was told for your base, it takes H plus ion, you get conjugate acid. Correct? So NH2 minus, you add one H plus ion, this becomes NH3. NH3, you add one H plus ion, this becomes NH4 plus. HCO minus, you add H plus ion, this becomes HCOH. So these are my conjugate acid. Correct? The species H2O, SCO3 minus, HCl4 minus, NH3 can act both as acid and base. Because it can lose proton, it can gain proton. Find the corresponding acid and base both. So I have, let me write like this. This is my conjugate acid and this is my conjugate base, right? And I have highlight all these values here: H2O, HCO3 minus, HSO4 minus, and NH3. So to give acid, to create acid, conjugate acid, what do you do? You have a base, you add H plus ion, you get conjugate acid, right? So you add H plus ion. So it adds H plus ion, H3O plus it will become, this will become H2CO3. I'm just adding H plus ion, this will become H2SO4 and this will become NH4 plus. Let's take conjugate base, you have to subtract H plus ion now, correct? Subtract H plus ion from H2O, this becomes OH minus ion. Subtract H plus ion from this becomes CO3 2 minus. Subtract H plus from SO4 minus, it becomes SO4 2 minus. NH3 you subtract H plus, it becomes NH2 minus. So if you see, same guy is acting as acid and acting as base. Remember, if you want to form conjugate acid, you have to supply H plus to make it acid. So it becomes conjugate acid. You want to make it conjugate base, take out H plus to make it conjugate base. Now the question that comes to our mind is, water, is it acid or base? It's a very good question actually in chemistry. The answer is water is both acid and base. We'll see how. See, water acts as acid base because it accepts proton. See, this is water, this is HCl, it becomes H3O plus. Water has taken one proton from H plus, became H3O plus. So water is a base. Water acts as acid also because it gives proton. For example, if you react water with ammonia, this becomes NH4 plus. That means water has given one proton to NH3 and becomes OH minus. So water is both acid and base. I'll just repeat once again. So if water, you react water with a strong acid, water behaves like a base. If you react water with a strong base or a base, water behaves like acid. For example, if you react water with ammonia, which is a base, water acts like an acid and loses proton, it becomes OH minus, conjugate base. Water, when you react with HCl, the acid, it gives proton to, it takes proton from H plus, HCl, it becomes H3O plus, and then it acts as base. So it's very funny chemical actually, water. It is both acid and base. And that's why it is actually neutral. We'll talk about pH scale and all, we'll talk why it is neutral. So after Arrhenius, we got Lowry and Bronstein. Then Lewis also gave the concept of acid and base. So in 1923, Lewis defined acid as species which are electron pair acceptors, and the base are the one which donates electron pair. Please note, for this chapter we'll be focusing more on the Bronstein and Lowry acid base, where it accepts H plus and OH minus. We'll not be focusing more on this Lewis acid and base, but since we are studying the history of acid and base, we have covered this. The Lewis acid is something which accepts electron pair, and the base is something which donates electron pair. And this was done because there was a demerit for the Bronstein and Lowry acid base, because BF3, if you see, doesn't have any proton at all, but still acts as acid, because it reacts with ammonia and it accepts the lone pair of electron. This is something which is acid, but the earlier definitions of acid could not prove it is acid. Only the litmus paper was proving it is acid, but the early definitions were not able to prove it. So if you see, this is the BF3 and this is NS3, it takes the lone pair, becomes this. So it accepts the electron. We'll take some example of Lewis acid and base. We will classify the species into Lewis acid and base and show how this reacts with. So for example, OH minus is what? It's base. Why? Because OH minus will take this H plus to becomes H2. F minus is also the base. Why base? Because F minus will also, even if you react with BF3, it will form BF4 minus. If you react with H plus, becomes HF. H plus is acid, right? Because you react H plus with OH minus, becomes H2. BCl3, the tricky part. This guy is acid, like BF3, because BCl3 plus NH3, if you see how it works, is this becomes H3 and BCl. It accepts the electron pair. So the Lewis acid is the best definition for acid and base, but for our chapter will not be using this definition. We will be taking the earlier definition. Let's take some questions now. Which of the followings are Lewis acid? So H2O is neutral, BF3 is acid, H plus is acid, NH4 plus is also acid because it will donate the H plus ions. Now we'll take ionization of acid and base. So we'll have already discussed this actually. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.